In this video, we'll be talking about conditional statements. A conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. So we have all of these symbols here that are given to us in the table that you need to fill in. P will be our hypothesis, and Q will stand for the conclusion. Any other letters that are given to us in a symbolic representation of a conditional statement will be variables. When we have the kind of like upside down V, it means and. The tilde here means not. The arrow means then. The double-sided arrow tells us if and only if. The three dots say therefore, and the V shape means or. When we use the not symbol, we are negating a statement. When you negate something, you write the opposite of it. So if the statement was, I like pie, the negation of that would be, I do not like pie. So our hypothesis is the statement that comes after if, and the conclusion is the statement that comes after then. So if I said, if I like pie, then I like desserts. So if would be the hypothesis, and the conclusion would be after the then. So the if is if I like pie, that's the hypothesis. The conclusion is then I like desserts. We can use these symbols and the hypothesis and conclusion to write them symbolically. So if P then Q is what this symbol means. So P and then the arrow Q. So the hypothesis and the conclusion is what we get when we have a conditional statement. So it's just an if-then statement. So if the battery dies, then your phone will shut down. That's a conditional statement because it follows the order if P, then Q. So P is the battery dying and Q is the phone shutting down. So if the battery dies, then the phone will shut down. The converse is just taking that and we're swapping the position there. So if Q, then P. So we say if the phone shuts down, then the battery is dead. So we're just switching the order there. We then have the inverse. The inverse means not P, or if not P, then not Q. So we're just taking the hypothesis and negating it, and then saying the conclusion would also be negated. So you take the opposite of both and keep them in that same order. So if the battery does not die, then your phone will not shut down. So remember that the little tilde means not that, so we're just negating it, and we're going to just keep them in the same order. The contrapositive, though, negates both and switches them. So if not Q, then not P. So if the phone does not shut down, then the battery is not dead. So we're just rearranging the order of the statement that was originally given to us by putting them in specific orders to show whether it's the converse, the inverse, or the contrapositive. Apply this with some statements here that are given. So if you would like to pause the video and try them on your own, go ahead and press play when you're ready to review. In the first example, it said if you live in New Jersey, then you live on the East Coast. So living in New Jersey is P, and living on the East Coast is Q. So to get the converse, we have to reverse them, and we would get this statement. If you live on the East Coast, then you live in New Jersey. This is false because if you live on the East Coast, you could live in many different states, including Maine, New York, Florida, or New Jersey. But New Jersey is not the only option there to say you live on the East Coast. So this is not always true, and we say it's false. For the inverse, we're taking not P, then not Q. So you get this statement. If you do not live in New Jersey, then you do not live on the East Coast. This is false as well, because if you do not live in New Jersey, then you could live in Pennsylvania and live on the East Coast. If you do not live in New Jersey, then you could be living in Maine, and you would be living on the East Coast. So this is not always true. For the contrapositive, we take not Q and then not P. So this is the statement that we get. If you do not live on the East Coast, then you do not live in New Jersey. So this is true, then you couldn't be living in New Jersey because you couldn't live in New Jersey and say you don't live on the East Coast. Go ahead and continue trying these and press play when you're ready to review them. So these are the statements that we get when we turn these into the converse, inverse, and contrapositive. So now we have to determine whether they're true or false. So if a polygon is a square, then it is a rectangle. This is true because to be a square, you have to have all the properties of a rectangle. If a polygon is not a rectangle, you have to have all the properties of a rectangle, and squares can all be called rectangles. So this would be true because if it can't can't be a rectangle, then it's not a square. If a polygon is not a square, then it is not a rectangle. This is false because a rectangle doesn't always have to be a square. So a rectangle could exist without having all four sides congruent and making it a square. So this one's true because they're saying it has to not be a square to not be a rectangle, which is not true. In our next one, if two angles are supplementary, then they have a sum of 180. This is true based on the definition of supplementary angles. If two angles do not have a sum of 180, then they are not supplementary. This is also true. They need to add up to 180 to be supplementary. And if two angles are not supplementary, then they do not have a sum of 180. Again, this is true because they need to add that sum to be called supplementary. And our last one, if two angles are acute, then they have a sum of 90. This is false because I could have two acute angles, one being 89 degrees and one being 89 degrees. Those would not have a sum of 90. If two angles do not have a sum of 90, then both angles are not acute. So if they don't have a sum of 90, it could be 180 for their sum, and both angles wouldn't be acute in that case, but we could have a sum of 80, and then both angles would have had to be less than 90, which would make them acute, so this is false. If both angles are not acute, then they do not have a sum of 90. So if they're not acute, then they would be obtuse, so 91 plus 91, and those would not have a sum of 90. That's going to be true because already more than one of those acute angles would be greater than 90 on its own. This is the last example that I would like you to try. So again, if you want to pause and then check your work when you're ready, that's great. So you can go ahead and check to make sure that your statements were right. The hypothesis here was that if two angles have a sum of 90, the conclusion was that both angles are acute. So not P would be two angles do not have a sum of 90. Not Q would be both angles are not acute. To write the converse, we flip-flop P and Q from their original order. So we say if both angles are acute, then they have a sum of 90. This would not be a true converse because we can prove with a counterexample that both angles could be acute, like 89 degrees and 89 degrees. We could add them up and they wouldn't have that sum of 90. So this is not always true. When we write the inverse, we take not P, then not Q. So we say if two angles do not have a sum of 90, then both angles are not acute. So if two angles do not have that sum of 90, they could have a sum that's less than 90 or greater than 90, in which case the angles could be acute or not. So that would also not be true all the time, so we'd say it's a false. In our last one, we write the contrapositive, not Q, then not P. So if both angles are not acute, then they do not have a sum of 90. If they are not acute, then they have to be greater than 90, and then they wouldn't have a sum of 90, so this one is true.